The agenda for today, as everyone is voting, after my introduction, sorry, I'll go back to the agenda. Perfect. So as I was saying, after my introduction, we will be jumping into the material for today. So polypropylene, what are its features? Why are we 3D printing with this material? What are the benefits? And then we will go on to the challenges of integrating a new material in a service bureau, in this case with a Sculpteo. And then we will jump to Prodways solution, which is a ProMaker P1000X, and how Sculpteo is using this additive solution. And then finally, we'll be looking at some more general applications before we jump, as I told you at the start, into a Q&A for 10 minutes. So if you have any questions for the speakers, please feel free to send them in throughout the presentation, and we'll have some time at the end to answer your questions. I have the poll here now with more than 50% that have voted, so I'm going to share the results right now. You should all be able to see that on your screen. I don't know if the panelists see that as well. Yes, so you can see that for the first question, the most used technology to manufacture PPP parts seems to be 3D printing, which makes sense if you're attending this webinar. How do you use 3D printing in your company? Mostly in-house, actually. And some do both, outsourcing and in-house. And then what is the most important factor to consider? We have the availability of materials, which is also convenient in this webinar. And then why do you use 3D printing? Well, it's a close tie for prototyping production, but R&D is the majority. So I will stop sharing, and we can jump back to the overview of the presentation. So I'm just going to give you a bit of an introduction and just some context. So as you may know, it's in the injection molding industry that PP has been very commonly used, mostly for storage and packaging applications due to its low cost and flexibility. And it was actually introduced in the 3D printing market some years ago, but it's not been there for a very, very long time. And so in terms of applications, polypropylene is a very versatile material for automotive, consumer, industrial, and medical applications because of its properties, which we're going to be delving into in just a moment with the speakers. And in this case, we're going to be looking at the integration of this material in a service bureau for the selective laser sintering process, so part of the powder bed fusion family of technologies. So of course, we're speaking about a powder material in this case. And we'll also be going to be discussing this in the context of Prodways industrial ProMaker P1000X solution. And what is interesting with this machine is that it can work with a wide range of materials, so the portfolio is quite complete, and it's well suited for production grade parts and large scale parts. And so if you follow the developments in additive manufacturing, you will have seen, and there's different studies that show this, that 3D printing technologies are being increasingly employed for more production applications and beyond just prototyping applications, which was the case at the start of the adoption of this technology. So it'll be interesting also to have the point of view of a service bureau on this. So let me present the speakers. So myself, who is moderating this webinar, I'm Carlotta, and I work for 3D Natives, which is an online magazine about 3D printing and the latest developments in this industry. And so we host events, but also these monthly webinars on different applications and with different companies. And I'm very pleased to be joined by Stefano, who is part of the production development team for the ProMaker P1000, and who is working currently as product marketing manager for the SLS range of 3D printers of Prodways. And he's going to be presenting Prodways in just a moment too. I'm also joined by Clément Moreau, who is the CEO of Sculpteo. So Sculpteo, which specializes in the 3D printing services for really any type of applications since 2009. And it was one of the first companies to make 3D printing technologies accessible. And he will also be telling you more about Sculpteo in just a second. And then finally, Adrian Rago, who is Technical Sales Manager for BASF Forward AM since early 2020, but he was working for the BASF group since 2018. And he will tell you more about BASF Forward AM, but BASF Forward AM, just to give you a short idea, it manufactures and sells 3D printing materials for a lot of different technologies from SLS, DLP, SLA, FDM, and it provides also different manufacturing services for additive solutions. So actually, I'm gonna let Adrian tell you more about BASF Forward AM, and we'll go through each of the companies now.
Thank you, Carlotta. Hi, everybody. So BASF Forward AM is exists since 2017, and it is the result of several acquisitions in the 3D printing industry. Before BASF it was also involved in 3D printing, but more as a raw material supplier to other manufacturers who would then supply the 3D printing industry. So now we make those powders, filaments, and resins, as you said, Carlotta, for the 3D printing industry. We do it ourselves. We are now 150 people only dedicated to additive manufacturing. And we have a global structure. I work for sales in Europe, but we also have sales and application technology centers in America and Asia. That I think that's it. I could go on and on and on, but yeah, this is BASF Forward AM in short.
Stefano, I'm letting you control the screen.
Okay. So about Prodways, we are additive manufacturing system manufacturer. Our technology are currently 3+1. The one that I'm following closer is the plastic powder laser sintering department and systems, and we have small to big size machine in our product portfolio. Of course, machine is just one part. We also have materials in collaboration with BASF and other players on the market. And one of the characteristics of our machine is that are open. Something that puts Prodways a bit apart compared to the other players on in the market. Then we have the resin and DLP, resin DLP, not vertical, but branch of machine. We have a proprietary technology. This is called moving light. So we have industrial productivity DLP machine with moving DLP that scroll across the surface to give the highest resolution possible all over the surface of the platform. And one of the more interesting vertical that we are following is the dental one. We have really great result in that. And then we have the wax drop on demand technology with our subsidiary Soliscape in the United States. Those are machines specially built for jewelry. High resolution to have the finest casting model for jewelry. And this is in general Prodways as a group. We also develop our own resin, talking about coming back slightly back on the resin DLP department with our subsidiary DeltaMed in Germany, and we develop our resin in this plant. That's it on my side.
Thank you. So at Sculpteo, we have 11 years of experience in 3D printing, which set up us as the dinosaur of this webinar. So we certified our factory in ISO 9001 version 2015 because we believe 3D printing is now a real additive manufacturing technology. That's why I created the company 10 years ago, or 11 years ago now, and we believe that now it's coming to be true, and we are actually printing parts for a wide, very broad range of customers. We do more or less all the major domains except maybe flying parts. So we don't do parts that goes into airplane motors. But except of that, we do pretty much everything. We have in-house capacities, printing capacities, I mean, for all the major polymer technologies like SLS, SLA, DLP, and FDM. And in total, it's around 50 people and 35 big industrial printers at Sculpteo.
Okay, I will now talk to you a bit about polypropylene itself, the material. So some of you may already be familiar with this material, but some may be not. So what is polypropylene? First of all, you are probably more familiar than you think you are with this material, since you wear it quite often since about a year. It's actually used for surgical masks. So if you didn't know polypropylene, polypropylene knows you very well from very close now. This material has been invented, discovered in the 50s, and it's now widely used in the traditional plastic industry, especially in injection molding. There is one very important thing that I want to make quite clear from the beginning regarding the PP for 3D printing is that we are talking about a true PP. It is 99.9 XXX% PP, the rest being the magic BASF formula that makes it printable. So it's not PP-like, it's a true PP. So why did we bring this this material to the market? Why the polypropylene? So first, customers often ask for materials in 3D printing that already exist for traditional technologies. It's often necessary to explain that the same materials in 3D printing have different mechanical properties, but this request sometimes or often makes sense, especially when talking about PP, which has very specific properties such as its chemical resistance. Indeed, both the injected molded PP and the 3D printed PP have this feature, so it makes totally sense for an OEM to ask for this material. And indeed, PP is very widespread. It's about 20% of all the plastic that is being used that is PP. Compared to PA12, for instance, PA12 is just 1% of the plastics used. The only plastic which is more used than PP would be PET. It is used in the packaging industry, you've mentioned that, Carlotta, but also in the automotive industry, widely for bumpers, dashboards, interiors, brake fluid reservoirs, pipes, etc. Also in other areas, packaging, cosmetic packaging, and many more. You can even find it in banknotes, where in some countries, which tells you a lot of the chemical resistance of the material, indeed. So sometimes it's easier to promote a material that is already widely known to a customer which is new to 3D printing, but who is familiar with plastic like PP. Another advantage of using a material that is widely used in traditional manufacturing is that, for instance, for prototyping, if you want to use 3D printing for prototyping, then go for, if you want to use for prototyping, then go for injection molding in PP. Then you can use a prototype already in PP from the beginning, which is much more convenient and will allow you to have faster development cycles. Also, PP can be welded to other PP parts, welded. So whether they are 3D printed or not, which means that you can 3D print a PP part and have it welded in an injected molded PP part without any problems. So you can combine the technologies for a better result. One other major reason why we brought this material to the market is cost. When it comes to the cost of a 3D printed part, material is not the main cost factor, but it is not negligible. So there was or there is a need for more affordable materials in the market. And PP is a commodity, as I said, it's widely used, so it's cheaper. Though careful, it's cheaper, but its performances are quite good still, as listed on this slide, the strengths and other characteristics. Indeed, often you can replace PA12 parts with PP parts for a lower price. And for many applications, it can perform just as fine or even better. And moving on the next slide, I can also tell you a bit more about the key features of polypropylene. So starting from the upper left corner, sustainability. Well, first of all, since PP is so widely used, recycling processes do exist for such a material, which is often not the case for other 3D printing materials, because often, 3D printing materials are not so much used, but with PP, you can recycle printed parts much more easily. And second of all, and it has to do with the high recyclability of the material, the fact that PP is highly recyclable, so you can reuse the refresh rate in the printer is quite high, which leads to less waste when during the printing process. The weldability, I've talked a bit about it. We have tested actually like 10 different or something like that, 10 different welding methods, all work just fine as they do with traditional PP. Often the welded area of the part is not even the most fragile area in the part. The lower density, that is also quite a nice feature, and it is true for PP. PP is the plastic with the lowest density of all. It is also true for 3D printing polypropylene. This can make this material particularly relevant for transportation applications where weight or lightness is a key topic. Also, as a consequence, you can fill up your machine with less kgs, with less kilograms, so it also drives the cost a bit down. High temperature, here in this case, high HDT, so heat deflection temperature. Just to give you an idea, the HDT-B is above 100 degrees, and the VCAT A is above 130 degrees Celsius in both cases, just to give you an idea. It's easy to process, and maybe we talk about that a bit later in the webinar. Translucency, no water uptake. This is quite interesting, and we can link that to chemical resistance and media tightness also. You can use this material with a very broad range of media, whether it's acid or basic or water. It can be a container for such media. It can be a container for any media. You can use it also to print a part that can be in contact with the fluids like oil in a car, for instance. And the material will keep its mechanical properties over time without any issues. Known material, I think I've talked about this enough. The fact that it's known is definitely an advantage, and also the high stiffness. That's it for polypropylene. I think I can leave the digital floor to Clément. Is it right? Yeah.
Yes, it's me. Yeah. So thank you, Adrien, for explaining how nice the PP is. But it's true also that in a service bureau, when we start, usually we start with PA12, just because machines are shipped with PA12. And then at some point, we have such a collection of machines, just like what you see on the illustration, and they all run PA12. And the reality is that when I go to my head of production and I say, okay, let's introduce PP, they tell me, no, Clément, you must be joking. We have 10 machines now, and they are all running in PA12. It's easy. My life is easy. I don't want to change that. And why is it so complex to change and to introduce some other material? Because it's a lot of problems that goes with the workflow, that goes with new powders, mixing powders. That you have to clean very much every day the machine if you change the material inside, and that's a big constraint. But at the same time, for the customer, it's also very important to have the right material. And Adrien just explained us that how nice is PP, how many nice perspectives comes with PP. So just the idea that we will reduce the scope of the company to PA12 only just because it's hard to use PA12. It's hard to use more than one powder in a factory is not something that is possible. So we decided that we want to introduce more material, and we decided also that we would like to introduce these materials. Maybe we can go to the next slide. So we decided we want more materials, and in reality, it's not just us that decides that. It's customer basis. It's we need something else because we need the customer, because the customer needs something else. One of the very important thing, and Adrien tell it also just before of PP, is that it goes into the yellow bin. It's completely recyclable, and today everyone knows that it's not an option. It starts to be really mandatory to have green options or green possibility, ecological possibilities for service bureau. So we decided, okay, let's go for PP as something that is at least recyclable, that has a chemical resistance, and that works quite well, even if it's quite different from PA12. So it's not PA12, it's not a replacement for PA12, but it has very nice characteristics. So adding this PP is a way to broaden the range of applications. That's clear. And also, it's a very important thing because we were almost sure that when we introduce a PP, we were going to have new application because it's a well-known material of the industry. A lot of parts are already done PP, so let's try to use this PP. You can go to the next slide, please. But then how do we integrate it? The first experiment we did with new powders in 2015 and 16, were by using one of our existing printers and try to clean it. Like each 2 days, we clean the printer and we change the powder inside, and it was a complete mess. So we decided we want to have a new printer, and also we want to have something that is not very expensive, not like a €1 million printer, because you never know if it will be successful. So the idea was, okay, let's go for something that is a good enough printer. We don't buy a €5,000 printer. It's a very much industrial printer. However, it's not a very, very expensive printer. It's not the biggest printer in the world, because when we want to integrate a new material, of course, we have to mitigate the risk. So we decided we want to have this Promaker P1000X printer to test the PP. And maybe Stefano, you will tell us a little bit more about the printer.
Yes. So of course, if we are pretty happy that Sculpteo choose the P1000X, there were reasons that Clément already briefly explained. So the fact that this machine has been the base machine where the polypropylene from BASF has been developed on is one of the machines, and so it natively works with polypropylene, and this was one of the first advantages. The fact that also from the Sculpteo point of view is that there's a real support from all the technician and application engineer from BASF and also Prodways to support the development of something that is widely used, as everyone said before, on the market, but is relatively new for the additive manufacturing world. Also, as Clément said before, it's an affordable machine, which is a good point. It was one of the main points that drove the development of the P1000 series from the original one to the new one. And this, of course, allows a smoother integration with an existing, let's say, factory that is running like a train all the time. You don't want to disrupt the production. You want to test something before saying, okay, we go full force with polypropylene, and also having an affordable type of printer allows you to, let's say, risk without sweating too much. One thing that we didn't say is that the P1000X, I will go back on that more later, is the evolution of another machine that has been tested remotely from Sculpteo before, and is the base version of the P1000, as the classic P1000 that is on the market since 2016, not long ago, to tell the truth. The fact is that the machine has been developed to be affordable. One of the key points for sure was not the productivity, because we were concentrating on something different, on the flexibility, on the price point, the ease of use, but productivity was not there, and it was not there for Sculpteo, because it's a service bureau. They need a high productivity machine, and between the first version of the P1000 and the P1000X, there's a big gap in terms of productivity. And now we are up to the needs of Sculpteo. This doesn't mean that the standard P1000 doesn't work for service bureau, but if you want productivity, of course, the X has been developed for this. So here I will just give a quick overview of what is the P1000X and the P1000 series in general. We wanted to have a faster machine. We wanted to improve the accuracy, thermal accuracy and geometric accuracy of the part that we print. And we wanted to make the full catalog of material that we have for the base P1000 available also for the P1000X. So this took some time to develop, but finally we are here and happy. Of course, our machines are open, I would say. Then each customer decide what is the best application and what is the advantage of having an open machine. We have customers that like to change material, not every day. This is an utopia. It's doable, but it's a bit utopic. But every 2 weeks, you can switch from TPU to polypropylene to P11 to the Stark, that is a very tough material that we introduced last year. And you can do it effortlessly, I would say. And all the materials are available. Then from a service bureau point of view, usually having one machine dedicated to one material, we know that is one of the standard way of using this machine. And this is how also Sculpteo is doing. So this machine is dedicated, the P1000X that they have is dedicated to polypropylene. That is also the material that we are going to discuss in this webinar. Then I wanted just to show this slide for people that already know the P1000 and want to have some extra information about the P1000X. So we made a test video that I should be able to run now. And you see we have on the left side of the screen the P1000X and the P1000 on the other side. So basically what we did is to multiply by a factor 2 the production speed of the machine. As I wrote in the note, is a productivity-oriented 3D printer. While the first P1000 is flexibility, of course, quality and basic productivity. When we thought about the P1000X, we said to ourselves, we need to make it faster. We needed to allow our customer to have a full build in one working day. And this is why we have increased also a bit the volume. We have a faster machine, but also bigger in terms of volume. With a 2 liters per hour average speed, you can run a full job in like 18, 19 hours, giving you all the time to load, unload the machine, and start a new job. This allows you to have a full cycle of 24 hours, and you can ship the parts to your customer if you're keen in loading the machine every day, each day. And so this was one of the goal that we had in mind when we designed the machine. Then the other goal was also to improve what is the thermal control of the machine. We know that in laser sintering is is quite the topic, is the topic. Having an accurate thermal control give you consistent part in terms of mechanical properties all over the surface. It allows you to have production consistency. So already with the P1000, we had incredible number of heating elements, infrared heating. We had 10 lamps. We kept the 10 lamps and we improved the sensor. So usually in SLS, you have one sensor that is measuring the temperature in whatever part of the part bed. For the P1000, we used 4 sensors. For the P1000X, we have a 24 points grid thermal field control. You see, it's not a thermal camera, what you see in the red area here. This is the grid of temperature that is being read in real time on the printer. And also here I have a quick video. You see in transparent the slice of the part that have been printed, and also you have a clear visible mapping, visual mapping of the temperature. And of course, all the information gathered by the sensor are used in feedback to control to adjust the temperature of the machine with a 24-point grid, which gives us, let's say, that is something unique in the market. We did something weird or unique in the market with the P1000 with 4 sensors. Here we push a bit the accelerator even more. So what we did with the P1000 X is still to give, to bring to the market a good SLS printer with the best cost, volume, and throughput combination altogether. So it's not just the price of the machine itself, it's not just the volume of the machine, and it's not just the speed. It's the mix of those 3 elements that made this machine a machine worth to have in your company. I jump briefly. I steal a bit the show to Clément, but just 2 seconds to speak about case study. Clément, we will show also some parts. Here is an example developed by one of our customers, which is Perilot in the United States. It's an example of how you can take advantage of the characteristic of polypropylene to deliver solution to your customer. So in this case, we are watching a part, you will see the printed part afterwards, that has a leading hinge, is like a 15 centimeter long part with a big leading hinge in the middle. And this is something that basically you could do with polypropylene and not a lot of other materials. Then, of course, the leading hinge has to be well designed to have the right thickness, but is something that for PA12, after 3 bends, you will have your parts that get broken. And this is not the case with this part that has been developed for aerospace. And you will see also that there's a post-treatment on this part, but we'll talk about that later. So leading hinges is one of the applications that you can develop and with polypropylene, and is one of the key strengths. Another typical application are snap fits, so elements that need to have a sort of ductility that usually before polypropylene you only had with the P11, I would say. But polypropylene shows better possibilities from this point of view. And you see here you have the part on the left is an element with 2 snap fit left and right. I have here, it's difficult to see because in the webcam it's not small. We have here some snap fit part that you can take and open. Also this, we printed some elements in the past with nylon 11. We think that polypropylene is a better material for this kind of application. On the right side, also the blue part is a small clip that inserts in the gray one, and you need to have ductility and flexibility to do that. I know that Clément has some parts to show. Maybe I hope that the audience will be able to zoom his window to better see the parts.
Yeah, so I also have some snap fit, and we made experiment with such device, for example. So very easy, and it actually snap. And this kind of hook actually works with the polypropylene. So it's right that we can achieve this kind of snap also with P11. This is the other material that would work. Living hinge are also quite nice, very flexible, and they actually work on under fatigue. So that's a very nice feature of this material. So it's for those kind of application, it's I would say at least as good and maybe better than PA11, and it has all the other advantage of PP versus PA11. So it's not PA11. It's also not a replacement for PA11, not a one-to-one replacement, but it shares some of the aspect of PA11, the living hinge. Yeah, I have also this part here, which is some spherical joint that we printed, cut to show how it works here. So we have a nice gap, and it's actually working, and we can insert and extract. So this kind of parts completely run, and they do not fail in polypropylene. It has been very easy to have them finished. So that's I think for this kind of application, it's a very nice material indeed. The fact that it's a little bit translucent is also very important, and maybe we can go to the next.
Yes, this just a small interlude. These are the parts that you saw in the previous slide, 3D printed. The white one is a bit burned, but it should be visible. The part on the left, you see that there's some coloring. We receive all the time a lot of questions about post-processing. We will talk about this later, but as you see from this example, of course, it's possible. You don't have to keep your parts white or translucent. Even if the translucency, translucency is also a cool feature. And so this is the other example.
Yeah, for this use case, in fact, so this is a finished part. So you see it's clear. It's a little bit translucent. So you see the light inside the tank and reservoir. So this kind of application are very good for automotive, where we have a lot of small reservoir like this one, trucks, automotive, defense. For this kind of application, this material is very nice and very useful. You have to think about the chemical resistance of the materials. It has nothing to see with PA11 or PA12. This material is actually really resistant. You could put oil inside, you could put alcohol or acid or anything that goes into a reservoir indeed would go correctly in this tank. So this is, I think this is really the kind of part that we print on a daily basis on the P1000X in polypropylene so far. It's a very for us. It's this is one of the main reason to have this machine and material on the portfolio so far.
Then in this part also, as everyone can see, we had also a very thick wall. It's not 1 centimeter, but 2 millimeters and something is start to have some also mechanical strengths. But this doesn't let's say hide the translucency effect. And here we took a picture of the empty tank, and also with some liquid inside. It's pretty clear that even with a 2 millimeters thick wall, the material is still translucent and shows the liquid inside. So even in case of pressure liquid and so on, you still can have a visual look of what is going inside your 3D printed part.
Thank you for the picture, because I didn't want to play in live with very thick liquid in a webinar.
No, and also you can put it on your desk. It can become a mess. So it's cool. We did it for you. Don't worry. So this is just a resume of those two case studies, but we could go on forever. The type of application that you can develop with the polypropylene are big as the polypropylene market it is now. So the limitation is more on the fantasy, on the size of the printer, because of course if you need to print a dashboard, the P1000 is cool, but it's a 36-liter machine. You don't have a lot of, you should print the part split in 6 and then weld them together, which is cool because you can weld the parts. But at this point, maybe printing a full dashboard on a P1000 is not the most efficient thing. But for many other applications in automotive and not only, I think that it's a good combination of relatively new additive manufacturing material and machine.
Just to add one detail, it's a big frustration to be forced to print on EPA 12. For me, it's a 10 years frustration actually. And now that we are part of this story and we are able to add new materials, having such a functional material, such a, I would say a real material, something that people in car industry know about, it's fantastic. Now we are able to print real functional part, and it's very important for us.
Yes, there's also the shift between what was before just prototyping, visual, sometimes prototyping and not even functional, to functional prototyping. And now, because the machines are more faster than before, are more open than before, you can experiment with new materials, and so you can go also in the final part, so mass customization, which is a shift that is not happening in 2020. It's a trend that is here since some years, and we see it growing. So no more prototyping, but having the real material that you use in the injected molded counterpart is the key. So welcome to the PP.
Are we jumping to the next slide?
The next slide is the thank you slide.
Well, thank you actually to the 3 speakers. We're going to jump to the Q&A now, and we've received quite a few questions in the Q&A. We received 19 questions, so we have about 15 minutes, so we'll try to answer as many as possible. Actually, just on the application side, someone was asking if it's also for medical applications. We didn't touch too much on this. The PP?
I think yes. Well, of course, Adriana took the example of the mask that is in these unfortunate times are something that we know very well, and is one of the application. Then I will let Adriana talk about that. But since in the medical area, every time you need to have your printed parts in contact with something that is usually liquid or can be dangerous, of course, the chemical properties, let's say, the chemical resistant properties of the polypropylene really help. Then I don't have here specific case of polypropylene for the medical market. Maybe Adrian has, but I think that the possibility, of course, is there.
PP is widely used in medical devices because of chemical resistance. I mean, that's quite kind of obvious. For the 3D printing PP, it's a bit of a case-by-case analysis where we would have to look at the specific requirements of such and such applications and check if that would work. or not, depending on the certification that we have. So I would say, let's have a look at this application and let's see how it can work. It's really case by case.
Okay, thank you. And well, we had a lot of questions on the machine, like the resolution, the printing speed. I think it will be interesting to just have the technical specs probably published after, or you can check. We can go through some of those in just a second. But I saw one or two questions about the main difference, because we were comparing back and forth PP and PA12 or PA11, but there was a specific question asking the main difference between PP and PA11.
They are quite numerous, I would say.
Mm-hmm.
It's a bit hard to answer. I mean, I could list them all. I would say PP, we've already said what were the advantages. PA11 also has some other. Also with PA11, you have a whole family with PA11 with glass bead field or carbon field, or even ESD PP, electrostatic discharge. So there are definitely other advantages.
Mm-hmm.
One of the reasons why our customer choose PP today is recyclability. So I mean real recyclability, because PP goes into the yellow bin. So far, it's the only material that we have in SLS that goes into the yellow bin in the majority of European countries. So that's one of the reasons why people choose PP. And the other thing is chemical resistance. So that's really the two big difference between PA11 and PP. And the other characteristics, I would say flexibility, durability, they are more or less the same between PA11 and PP.
Yeah, we received quite a few questions asking to compare PP with PA11 or P12, but I guess that's a whole other discussion, and we could list quite a few things. In terms of, I also saw a few times in terms of the surface finish. So what is the surface like of a PP part? Yeah, I saw that question a few times, if you could tell us a little bit more, and what sort of finishing solutions are possible.
So let's say that the surface compared to other materials, mostly PA12, is a bit more rough. It feels, but it's just a feeling, a bit more porous, but it's just the state of surface, and it's because the material is itself. Then it's not porous at all because it's watertight, it's airtight, so it's just a surface finish that is different. Like many other materials in additive manufacturing, post-processing is something doable. One of the big trend lately in the post-processing is the chemical smoothing. Of course, polypropylene is chemical resistant, so it's not like that you can do chemical smoothing on polypropylene. But I heard that someone is working on that, and maybe Clement and Adrian can tell something more about that, if it's possible. Of course, everything that is mechanical in terms of mechanical abrasion, shot pinning, tumbling, all these type of post-processing are you can apply them to polypropylene printed parts to have a better surface finishing compared to the surface finishing that you have as it is out of the machine, out of the cake. Then you had also a question about the resolution, if I heard well.
Yeah, I did mention that we received a few questions, yeah, on the machine itself and what sort of resolution, yeah, it can achieve.
Just a quick note about the resolution. Talking about resolution in laser sintering is a bit is not totally correct, because there's not a real resolution. We are not talking about a DLP printer with a, you know, there's a projector and you have pixel that determine your resolution. What you can say here is the minimal wall thickness that you can achieve, and this really depends on the laser beam, the size of the laser beam that that you have on your machine, and usually this is around between 40 to 400, 500 microns, so half millimeter. half millimeter is the smallest feature that you can print. Is not that we suggest you to print half millimeter walls. It's true that is the thinnest thing that you could see printed on a laser sintering machine, but this doesn't have any kind of mechanical properties. We suggest also for PP something like 0.8 millimeter as a minimal wall thickness to have some kind of mechanical properties.
Okay. I don't know if Clément and Adrian have something to add, or I can move on to the next question.
Just to what you said before, Stefano, about chemical smoothing. So it is at a very early stage, but it seems that it is possible indeed. It's not done by BASF, but some are working on it, I would say, so it might come soon. But more, there's also some questions about coating as well. So what I can say is that we can coat the PP. Also, it's a bit challenging as well because of the chemical resistance of the material. But and at BASF we do have coatings for powders for 3D for SLS printed part. With PP we have to add a primer, so another layer. So the actual coating can have this adhesion to the part, and we are in the process of developing such a primer in order to be able to coat the PP, and then we are able to do basically any color. We can do some color matching, and also we can match some effects if you want metallic effects or something like that, quite special. This is something that we can do.
Okay, great. So I'm taking the questions one by one now. So we have, how many powder uses are you typically getting before you need to scrap the powder batch? What indicators are you seeing for scrapping?
So we don't scrap the powder batch. So we recycle powder with a 30 to 40% refresh rate, and we don't need to scrap the powder batch.
Okay, so that was for a few people were asking about the refresh rate as well. So it's 30 to 40%. Yeah. I'll let you talk. Yeah, if you want to.
Yeah. I mean, there are two options in this kind of situation. Either you go with a very small refresh rate, and after 10 runs, for example, you scrap everything and you start again. But we don't do that, and we don't recommend to do that. We really better go with a steady refresh rate, something like 30 to 40%, depending on the build job density. And from this, we can continuously add fresh powder in the build job, and we never need to scrap and start again.
And in terms of switching powders on the P1000X, how easy is it to print with different materials and make that switch? I saw that question twice as well.
So it's super easy, of course. No.
You want me to give just one detail on this, Stefano?
Yes, sure.
The machine architecture is quite simple. It's not a machine with a lot of tubings and things like that actually make it difficult to change material. This machine, when you open the machine, you see the tank of fresh powder, and because of that, it's quite easy to change the powder.
Of course, the cleaning for who is not into laser sintering is not just about the machine. It's also about the post-processing tool that you use, like the breakout station and so on. But it's true that having bottom feeding type of machine where the powders come from the bottom and raises up. So like Clément said, that there are not tubes coming from the top or a complex recycling system within the machine. Everything you have to clean is on site. So once you pass with the vacuum cleaner on the surface of the build surface, on the feeders, and you clean the optic window, you're ready to go and to change material. Of course, if you stay on the white materials and you switch from TPU to polypropylene and you come back, is not a big issue. If you switch to a radically different temperature material, like, I don't know, you switch from TPU to P11, you need to really be careful in, even if it's easy to clean, but to clean really in every corner of the machine, because the powder that will overmelt, and then you have to scrap it maybe with a small knife. Or when you switch from a black to a white powder, also in this case, you really do need to take care of a deep cleaning. But as I said before, it's easy. Everything you have to clean is on site. There's nothing really hidden.
Also at Sculpteo, when we share a machine between two materials, we never share the post-processing station. So the unpacking station, we dedicate them to one material. It's less money. It's something that we can afford. One breakout station per material. This is needed.
Because also the sieve, to clean the sieve deeply is not an easy task. So yes, it makes sense to have a separate post-processing.
Perfect. I'm gonna wrap it up with a last question on the price of the part, and if you could give us a few more details on that, on the price of PP and.
Do you want to answer, Stefano, or do?
Well, either way, but let's say that compared to we're talking just about the price per kilo of the powder. It's then depend on the quantity, but it's around the 20% less, 20-25% less than PA12, generally speaking. Then of course it depends on the quantity that you're going to purchase. Of course, there will be different type of discount. But this is not the only element that you need to take in consideration. Is also the lower refresh rate by 10 or 20% compared to the PA12 gives you an extra advantage in terms of cost per part, or let's say a return over the investment, because it's not just the price per kilo that gives you the cost per part or cost per usage of your machine. Is also how much you can recycle your powder, and this affects in the medium long term a lot your return over an investment.
And also, if I may add, Stefano, the lower density of the PP, it's lighter, so for a build job.
Yes, it's true. Then there are some technicalities that the drop feed that you have to do with polypropylene is not the same drop feed that you have on PA12 or PA11. So you might have some, you put less kilo of powder, but then you have slightly more powder that finish in the refresh bins. So it really depends, but it's true that having a lighter material with a lesser density helps also in filling the machine faster.
Well, great. Well, we have managed to wrap this up exactly in an hour, so that's perfect. And just to let you know that we did have quite a few, when you were talking about just the material portfolio that is compatible with this machine, we of course had a lot of questions about other materials. So I definitely encourage anyone that is interested to reach out to a specialist, and in this case it would make perfect sense to reach out to Stefano, Clément, or Adrian and the companies after this webinar if you have any questions on the materials or on the system. Just to let you know again, for anyone that joined a bit after the introduction, that this is going to be available on YouTube. The recording of this webinar is going to be available on YouTube, so you can have a look again or share it with anyone that might be interested. And you'll find it also on 3D Natives with a little recap article. So again, thank you to the three speakers, Stefano, Clément, Adrian, for joining today and for participating. It was great to have your knowledge and your expertise on this subject, and I hope to see all of you very soon.
Thank you.
Thanks
very
to
much,
everyone.
Carlotta.
Thank you.
Thank you.
Thank you.
Thank you.
Have a great day,
Bye.
everyone. Bye-bye.
Have a good
Bye-bye.
day.